Okay, so now we come to the second part of motion along a straight line. Okay, we will discuss some examples. Right, example 14. A stone is thrown up vertically from a place 10 meters from the ground with the initial velocity of 23 meters per second. Okay, after t seconds, the height of the stone from the ground is given by s equal to -5t squared plus 23t plus 10. Okay, so from the statement we have, okay, we have here is this 10 meter, okay, from the ground, and we have a stone that is thrown away, okay, with the initial velocity here okay, we have v naught equal to 23 meter per second. Okay, and after t seconds, the height, okay, so s equal to -5t squared plus 23 plus 10. So this is the height, okay, the stone from the ground. Right, A, find the time when the stone reaches the highest position from the ground. B, calculate the maximum height. And C, find the time when the stone touches the ground again. Okay, so let's try the first question. Okay, we need to find the time when the stone reaches the highest position from the ground. So we have the keyword, which is the highest position. Okay, so highest positions means we have v equal to 0. Okay, and we have v which is equal to ds over dt. So what we need to do is to differentiate s with respect to t. Okay, so differentiate s, so we will get -10t plus 23. Okay, so to get we have the highest position is when v equal to 0. Right, so from here we can solve for t. Okay, so we'll have 10t is equal to 23, so t equal to 23 over 10, which is equal to 2.3 seconds. Okay, so the stone will reach the highest position from the ground at t equal to 2.3 seconds. Okay, next, okay, calculate the maximum height. Okay, so we have just now it reached the highest position at t equal to 2.3 seconds. Okay, so therefore we will have the maximum height is, we have s when t is equal to 2.3. Okay, so we'll have here -5 times 2.3 square plus 23 times 2.3 plus 10. Okay, solve this algebraic equation. So you will have x or s just now is equal to 36.45 meter. Okay, so the maximum height when t equal to 2.3 second is equal to 36.45 meter. Right, okay, next. Okay, so now we move to C. Okay, find the time when the stone touches the ground again. Okay, we have just now this one. Okay, we throw the stone and this is the ground. Okay, so when the stone touch the ground, we have s equal to 0. Okay, so what you need to do is set s equal to 0. So you have negative 5t squared plus 23t plus 10 equal to 0. Okay, so solve for t. So you can use your calculator, or we factorize it, and you will have this one 5t plus 2 and t minus 5 equal to 0. So from here you will get t equal to negative 2 over 5, or t equal to 5. Okay, so since we don't have t as negative, we don't have time as negative numbers, so we will choose t equal to 5. Okay, alright, so this is the answers for example 14. Okay, let's move to example 15. Okay, a particle is moving along a straight line so that its position from the fixed point A at any time t seconds is given by x equal to t squared minus 5t plus 6. Okay, find its initial position, B, its initial velocity, C, the first time the particle passes A and find the velocity at that time, and D, the second time the particle passes A again and determine the velocity at that time. Okay, so the first question is to find its initial position. Okay, initial positions, we have x. X is the displacement or the position. So initial means that we have t equal to 0. Okay, so what you need to do is to find x when t equal to 0. So we have 0 squared minus 5 times 0 plus 6 equal to 6. Okay, and the unit normally we just write as meter. So this is the initial velocity, initial position. So B, okay, find its initial velocity. So we know that V is equal to dx over dt, which means that you need to differentiate x with respect to t. So you have 2t minus 5. Okay, so v equal to 2t minus 5. So the initial velocity, which means that we need to find the value of v when t equal to 0. So we substitute t equal to 0, and we'll have negative 5 meter per second. Okay, so I found the initial position and initial velocity. Next, okay, find the first time the particle passes A and find the velocity at that time. Okay, so the particle is moving along a straight line so that its position from the fixed point A. So A is the fixed point or the starting point. So when it passes A, which means that we have at x equal to 0. Okay, so what we need to do is to have the quadratic equation where we set it as equal to 0. Okay, so factorize to get the values of t. So we can have t minus 3 here times t minus 2, which is equal to 0. Sorry, this one is plus. Okay, right. So from here you will have t equal to 3 and also t equal to 2. Okay, so we have 2t now. So the first time we will choose as t equal to 2. Okay, so the first t is t equal to 2. Okay, and then find the velocity at that time. So we need to find v at t equal to 2. So just now we have v t is equal to 2t minus 5. Okay, so when t equal to 2, so we'll have 4 minus 1, which is equal to -1 meter per second. Okay, so this is the velocity at the first time which the particle passes A. Okay, right, so the last question. Okay, find the second time the particle passes A again. Okay, so just now we have two values of t, which is t over 3 and t over 2. So the first time is t equal to 2, and second time that the particle passes A is at t equal to 3. Okay, so we have t equal to 3. Okay, and the velocity at that time, okay, we have v at t equal to 3, which is we have 2 times 3 minus 5, which is equal to 6 minus 5. We have 1 meter per second. Okay, alright, so this is the solution for example 15. Okay, so that's all for the application of differentiation. Okay, so we have discussed 4 applications of differentiation. So you can try all the tutorials that I've given to you. Okay, alright, so that's all. Thank you.